Hi everyone, today we're going to put together a common emitter amplifier using a potentiometer. The potentiometer is actually shown here. This is the symbol of the potentiometer, and it actually looks like a resistor with an arrow in the middle of it, right here. On a circuit, this symbol is associated with a number like 10K that is written on the circuit, or 100K, or 1K, any value it can be. And what it means that this is the maximum resistor that can happen between the first and the second and the third legs. Let's call this first, second, and third leg. And what a potentiometer does is that it adjusts the resistor between the first and the second leg and the second leg and the third leg. So now using a potentiometer, you actually have two resistors, R1 and R2, and their values can be changed. But what matters is that the maximum value between leg 1 and 3, which is R1 plus R2, is maximally 10K here, for example. And both of these values are going to be less than 10K. How does it do it? So a potentiometer actually looks like this. As you can see, just like the symbol, it has three legs. This is the first, the third, and the middle one. It can even be this way, so this would be the first leg. It doesn't matter which way you put it in the circuit, but what matters is that all of these three legs have to be in different nodes on a breadboard. So for example, we never put them like this here, because that means that this way the first and the third leg are going to be connected together. So what we want to do is to choose three different nodes for this. So I'm going to choose node 40, 41, and 42, or sorry, it's actually this way, 40, 39, and 38 for this potentiometer. So I'm going to put it right here. Then now, based on this circuit, it says now we can work toward the other components. For example, it shows in the circuit that the second leg of the potentiometer, or the middle leg, is actually connected to a 100K ohm. So what we want to do is connect this circuit. The middle leg is right here in the middle. So we want to put this 100K exactly in the same row right here. So look, this is the middle leg, and then the other side of the 100K can go anywhere here, any other node, right? Now we get to the BJT right here. The BJT, it's an NPN, so we know how to put it in the circuit. The 100K goes to the base of this BJT, so we're going to put the base exactly where the 100K is connected. Then we put the collector and the emitter. Now what else do we have? We have a 10K resistor that goes from the collector to actually the first leg of this potentiometer. So we can connect the collector right here. I want to bring it closer. 10K goes from here to the first leg of the potentiometer, which was connected to this node. So I'm going to fix this and show it to you. Okay, any of these nodes would work. So now in the emitter, we have 1.5K emitter resistor connected to the emitter and the other leg of the potentiometer. So let's do the same here. So we have 1.5. This is my 1.5 resistor, 1.5K resistor. So it goes from the emitter to, things are moving here, to the other leg of the potentiometer. You can see it right here. So now what is left to do is to connect the ground to where the 1.5K is and the 10K are connected, which is right this point. So you can just bring a wire, connect it to the ground of the your voltage source and connect it to here, and then the 12 volt is going to be connected to the 10K and the potentiometer, which is right here. So you can see. Now, why do we use the potentiometer? You can use the potentiometer to change R1 and R2, and then what it does is actually changing the voltage here. So as you can guess, if you, instead of this 10K, you put R1 plus R2 here connected to the ground, 12 volt. Now this is like a voltage divider. By changing R2 over R1 plus R2 changes, and then the voltage here is going to be this number multiplied by 12 volt. So when you change R2 here, you are basically changing V here, and then that would mean you're changing the bias voltage of this BJT. So that's what you can do. How do we change the value? I don't have anything here, but you basically put a screwdriver or something here and then rotate it, rotate this point, and you can basically change that. Let me see, I can find something here. So okay, I'm trying just like this. So you would change this. That means that R2 goes from 0 to 10K. And you can basically measure R2 by either measuring the voltage at this point or any other way. Basically, you can even connect a digital multimeter here and then check that. But that's it. Thank you.